So welcome everyone to the video. And in this video, what I'm going to be doing is I'm going to be discussing a very simple quantitative aptitude concept. I'm going to be discussing the derivation of this concept. And then at the end of this concept, I'm going to give you a question which you can solve by using the same concept that we're going to be discussing in today's class. So let's start by looking at what concept I'm going to be discussing. So it's a geometry based concept that I'm going to be looking at today. And I have made a small problem statement to help us understand what this concept is. So the problem statement which I want to solve here is that if P is any arbitrary point which is present inside an equilateral triangle of side X, then what is the sum of the distances of this point P from the three sides of the triangle? So let me try and solve this, and then if I get to an answer, then we can probably look at what concept I'm trying to discuss here. So let me draw a very simple figure of an equilateral triangle and say, suppose, let me call that triangle ABC. And within this, I'm just taking a random arbitrary point P such that PX, PY and PZ are the perpendiculars which are being dropped from this point P onto the three sides AB, BC and AC respectively. So basically what I'm trying to do is that I'm trying to find the sum of these three perpendicular distances of P from the three sides of the triangle. So I'm trying to find out if I can find out the value of PX plus PY plus PZ in terms of X, where X is the length of the side of this equilateral triangle. Okay. So let me make a few constructions to this end and see whether I can achieve what I'm trying to. So the constructions that I'm wanting to make right now is, let me join this point P with the three vertices of the triangle. So let me join PA, PC and PB. So these three constructions, when I make them, then this equilateral triangle ABC gets divided into three smaller triangles, which are triangle APB, triangle BPC and triangle APC. Excuse me, triangle APC. So sum of the areas of these three triangles will be equal to triangle ABC's area. So that's a very basic thing that we can just visually look at this figure and verify. Right. So now if I look at each of these triangles, triangles APB, BPC and APC, I have got an altitude of each of these triangles present in the figure right now. Because an altitude is a perpendicular drop from one vertex onto the opposite side. So for triangle APB, PX is an altitude, which means a triangle APB's area can be written as half into PX into AB. Okay, let me, because the X and X is confusing, so let me write it like this, half into PX into AB. Similarly, triangle BPC's area can be written as half into PY into BC. And triangle APC's area can be written as half into PZ into AC. And triangle ABC, since it's an equilateral triangle, I can just write this as half into height, let me call it, or base is just X because all the sides have the length X, into height. So half into X into height is the area of triangle ABC. So now what can happen is I can take all the halves common and halves will get cancelled. And also AB, BC and AC all are equal to X. So I can take X common from the left hand side here and I'll get X into PX plus PY plus PZ is equal to X into height of the equilateral triangle. So when the X's get cancelled, then I'm left with the fact that PX plus PY plus PZ is equal to height of this equilateral triangle. And we know that the formula for height of an equilateral triangle from basic trigonometry, which can be derived, is root 3 by 2 into side. And in this case, the side is of the length X. So that is what is the concept. So sum of the perpendicular distances of the point P from the three sides of the triangle is root 3 by 2 into X, where the triangle is an equilateral triangle and P is any arbitrary point within it. Okay. So this is the concept that I wanted to discuss. That if I take any point within an equilateral triangle, then the perpendicular distance of that point from the three sides of a triangle will always be constant. and that sum will be equal to the height of the equilateral triangle. Now this very basic concept or this very basic principle is what in mathematics is known as the Viviani's theorem. So Viviani's theorem states that sum of the distances from any interior point to the sides of an equilateral triangle equals the length of the triangle's altitude. And this theorem was first stated by Vincenzo Viviani, who is a very famous Italian mathematician. In fact, he was a disciple of Galileo and also of Torricelli, and he has contributed several other things to the field of mathematics, including this particular theorem. So now that we are clear as to what the concept is and how this concept came into being, so with this concept, I'm going to give you a question that can be solved. So the question based on this is a probability and geometry hybrid kind of a question. So the question is that if you have a stick of a certain constant length and you break that stick into 3 pieces, then what is the probability that the 3 pieces can form the 3 sides of a triangle? What's the probability that the 3 pieces that you get after breaking a stick into 3 pieces will form the 3 sides of a triangle? Okay, so you can try this out, and if you are reaching the answers, you can put your answers on the comments. I'm going to share a solution video to this particular question a bit later. So thank you so much and have a great day.